Hi everyone, welcome to the technical review presentation for Wendy's RV Park. In our presentation we have Charles, Chen, Ilya, Isabel, Vahid, and myself, Andy. Today we'll be going over the overview of the requirements, the review of the internal system structure, the sample HCI elements, technical challenges, complex solutions, and the plan for project completion. Hi, I'll be going over the requirements of our project. In this case, I'll be going over the business imperative and the user requirements. So, Wendy's RV Park is one of the few areas in Alberta that allows for long-term stays for the RV community. It consists of 290 individually owned RV lots, as well as a gym, pool, lounge, and much more. The client wants us to create an updated and more modern site for current and any potential RV park users. The reason for this is because the previous site was lacking many features and many parts of the sites had broken links and it looked like the site hadn't been updated in years, to be honest. What the client envisions for the future site includes things such as an event planner, user messaging, and forums. For marketability, the new website has to present a newer, more modern look compared to the previous site. Mainly, the new site has to be designed for the target audience in mind. The main demographic in the Wendy's RV Park is just older people, maybe they're even retired, so they may not be as familiar with current technology, so they know how to use a computer and stuff, obviously, but at the same time, making it too complex and adding too many unnecessary features would just lead to an unreceptive response to the website. So mainly it has to be functional and responsive and has a fast loading speed. So the main features of the website is being able to see and join any potential events. So how it works is there's going to be a calendar feature where you can just click on a date, you can create an event, or if an event is already there, you can view the event details and just click on it to join the event or RSVP to go to the event. The users must also have a method of communication amongst themselves, so things such as just messaging, and users should have the capability to add their own documents to the website and view them, so you can add things to the website such as pictures, documents, all that sort of stuff. Admin users must also have the privilege to make day-to-day changes to the website. Some example of those changes could be adding pictures to the website, adding new events to the website, taking down unwanted posts, stuff that just breaks the rules. And their other main responsibility is to approve or reject any new account creation requests. So when a user wants to create an account, the admin just goes through the request manually and approves or rejects it. The potential user base is going to be quite small, less than 1,000 people, so that's why we have a manual approve or reject feature. And lastly, the new site should be created with common programming languages and frameworks for any potential future changes. And the reason for this is because in the future, when we hand over the project to the client, if they want to make changes, we don't want the site to be coded in some obscure language that nobody knows of. That's why we're choosing really common and effective languages and frameworks to work on. So we have React, JavaScript, which is just something incredibly popular right now and has been growing in popularity for many years. We have Spring Boot framework for the API and just sending requests to the backend from the front end. And we have PostgreSQL as our main database server. And next up, we have Isabel with the internal system structure.
I'm going to explain how our application works internally. First, I'm going to go through some tech stacks we have used for this project. So in the client side, we use React to create a single page application. We use Ant Design to help us for the GUI creating. We also use React Router to navigate between different components. because this is a single page application. We also use excerpts to fetch data from the server API. In the server, we use a Java framework, which is a Spring Boot. We use the Postgres for the database, use Spring Data JPA to interact with the database. We also use the Keycloak server to manage all the user authentication and authorization. So how does all the pieces work together? Let's take a look at this picture. When users land on the view page, they can send a request to the server, which starts from the control layer. So the control layer will receive all the client requests and then call the method from the service layer. The service layer will call the method from the database access layer. Each layer has the response data to the caller layer. In the end, the controller layer will return a JSON format data to the client side. The client side will re-render its components based on the response data. In the client side, we have all those sections. They are all component based, and then they are reusable. So we use router to navigate between different components or sections. In the server side, each layer has their own function. The control layer receives all the client requests, and then each request has a unique endpoint. The control layer will call the corresponding method from the service layer. In the service layer, it handles all the business logic here, includes validated the input data, decide what data to be returned to the client side. The repository layer are some interfaces that interact with the database and to retrieve the requested data. For the domain layer are some Java entities have been mapped to the tables in the database. In the end, the Keycloak server, we use it to manage all the user authentication and authorization. So this is how our application works internally, and then what are some functions for each part. Next, Ilia is going to talk about some UI components.
Thank you, Isabel. Today, I will show you sample human-computer interaction elements of our website. Simply put, I will show some UI elements of the website, describe how they function, and how they follow the principles of good user interface and user experience design. I will be showing the following elements: the navigation menu, homepage, slideshow, and event page, specifically event calendar, side menu, and event creation screen. The navigation menu is a component present on every page. It is affixed to the left side of the website and spans from the top to bottom of the browser window. Navigation menu has three parts: logo, which is affixed to the top of the menu and was specifically designed with the same color scheme as the website in mind; footer, which is affixed to the bottom of the menu and provides links to the login and register forms; it changes to display the name of the logged in user and a way to log out; and finally, the navigation links. Each link leads to the corresponding page of the website. All links have useful icons that help users see where to go without even reading the text. Slideshow takes most of the homepage, with just about us and contact information located under it. The slideshow rotates through the pictures of the park and let visitors of the website see what the park looks like and potentially interest them in registering an account and renting a spot. On the event page, we have a full calendar. On it, users can see all the events planned for the month. Each day displays a list of events in the order they occur. Clicking on one of the events will open up a more detailed description of the event. And to close this pop-up, users can click on Close button, press on X in the top right corner, or click anywhere outside of the pop-up window. We included many options to close the pop-ups, so users with different levels of experience with internet don't have to look for one appropriate way and instead use their preferred one. Next is a side menu. It has two parts to it, search and filter, where users can search for specific events by entering parts of the event titles or parts of event description, or filter by the category and location of events. Search and filter functions will leave only the events that are related to the search in the event list, which is a list of all events that will happen in the future and is sorted by date those events were created, so users will see the newest events first. Click and View displays more information about the events in the same way that Calendar does it. Finally, we have a simple event creation screen with a form for creating events. Registered users can fill in all the fields and optionally add a file attachment such as schedule for events, a picture, or a list of people attending the event. If an event was created successfully, a familiar pop-up will appear to show the entered information and to confirm that the event was created. This is it for my part. I will pass it to Chen.
Hello, my name is Chen, and I'm going to introduce you about technical challenges that we have made during the development progress. The first challenge is learn new technologies. In order to fully complete our project with quality, we decided to apply some new technologies in our project, including but not limited to Docker, React, Spring, aspect-oriented programming, and the identity server. According to the division of work, we all need to learn something new to finish our own part of work. We all spend our holiday time learning these new technologies. Some of us even start earlier than that. This is probably the most difficult challenge since it wasn't easy to learn something new in a short period of time. So far, we still have a lot of new problems with these new technologies every day. So we will keep learning to solve these problems one by one. Our next challenge is what we are most familiar with may not be the most suitable for our project. We have learned many different development tools during different courses, like BlueG, NetBeans, and Eclipse. But even we are very familiar with these development tools, it doesn't mean they are the most suitable development tools for our project. Since we are using some new technologies to our project, we have to consider which development tools works better for these new technologies. And all team members need to get familiar with the new technology and the development tools as soon as possible. The third challenge is system and application integration. After we have learned some new technologies, how should we integrate them together into our project became our third biggest technical challenges. Our group members were digging down the documentations to try to find useful information about all of the functionalities. And some of the functionalities need to be tried on different versions to find the best version for us. To ensure an optimum integration plan for the project, we evaluated and test different ideas in our group meeting.
In this section, I'm going to talk about the complex solution that we implemented in our project, and that is related to security. Any secure application works based on the IEEE security factors. I stands for identification, meaning that the application should be able to store some of the basic user information like their name, their username, their password in a secure way, and attributes as such. Based on those attributes, the application should be authenticate users later, meaning that it should be able to find out if they are actually who they claim to be when they want to sign in. Also, it should be able to authorize them, meaning that it should be able to allow them access the resources that they have the privilege to access. And also, it should be able to store some accounting information, meaning it should be able to tell the admins later on who wanted to access what and who did what in the application. We could reinvent the wheel for our project, but we decided to go with well-established, well-programmed, and well-tested projects out there. And we chose Keycloak. Keycloak is an open source identity and access management solution bred by Red Hat and you can find it in the GitHub repository on the screen. It is friendly with browsers, mobiles, and it is easy to implement it in cloud. And it can manage many accounts very easily without any headaches for the admins. Keyclocks has some built-in features like SSO. It has an admin console that you can go and change some of the core behaviors of the Keyclock authorization and authentication server. It has some login forms built into it. It has account management section where you can go and manage the accounts and the users of your application. It is easy to implement multi-factor authentication in the Keyclock server, and also it has social login capabilities, meaning that the users can use their Facebook account if it is configured on the server. They can use their Facebook, Twitter, or maybe GitHub account to sign into the application. There are two ways to implement Keyclock: standalone and embedded. We went and chose the embedded version because it was giving us more freedom on what we want to implement and start the application with, and what we don't want. For example, right now we don't need the social logins, so we turn them off when the project starts up. So in the standalone version, the Keyclock server just comes up fully configured with support for everything. In the embedded version, we had the ability to turn off some of the features, like, as I said, the social logins or the login forms, the endpoints, the internal endpoints of the Keyclock itself. We could just hide them behind the Keyclock authorization and authentication server and use our login forms, our own login endpoints, and have the Keyclock as a backend for our authentication and authorization requirements. Of course, it is possible to go and change some of the behaviors and add or turn on some of the behaviors of the Keyclock in the admin console, but having what we want at the moment that we start up the application helped us to run the application faster, and it helped us to customize the Keyclock behavior to what we need right now, and and just don't start up the things that they are not required as of now. Next, I turn to Charles to talk about the plan of completion of the project, and thank you for listening.
Thank you, Vahid. I'll be now going over our plan of completion. So regarding the progress, we are currently pretty much done with the backend. We are just missing some minor components to the backend, but the majority of our remaining time will be spent working on the front end and getting the styling and the missing components implemented. So some challenges we faced along the way were time frame constraints. So we didn't expect some tasks to take as long as we thought, so we had to redesign our planning and take that into consideration more. As well as school priorities, we had other work that was needed to be done, so we didn't have as much time to work on the capstone, so that also caused some slight delays. And as well as task breakdown, so some of the tasks were getting complete, but later on we had to revisit them because they were missing certain aspect or functionalities to them. So along the way we've adopted a few things. So 3 meetings a week really gets us a good base, and we're able to discuss whatever we need for the week. So we are able to discuss what you've done, what needs to be worked on, and issues and concern on whoever has any. As well, we communicate pretty much on the daily. I usually get 1 or 2 message just saying, oh, I've completed this, or I need this, or can you check this, or just anything in general. So it really makes sure that everyone's working, and then we are not falling behind. We've also implemented 2 Trello boards, so let me show you guys those. We have a board regarding the feedback, so this allows us to deal with any feedback we receive from our client and address those feedback and issues. As well as we have a to-do list. In our to-do list we have small components and big components, so this allows us to see what's left to be done, and as well inside each component we break down into checklists, so it allows us to really break down the tasks needed and ensure that the component is getting completed to its fullest. We've also added a timeline, so this allows to see what is due when, and also in the progress we show who's working on what component. And the last thing we've adopted is something that our instructors instructed us to do, is to keep track of the time spent working on on the capstone itself, just to ensure that we are working on it and that it's getting done. Thank you for watching. Take care, everyone. And that sums up our presentation. I hope that you understood a bit better our project, and thank you everyone for watching. Take care.